My bad. We started late. Okay. Oh.
Tell me looking for you. Okay. I don't have any.
Write down your name.
Or can I have an iPad? This is from.
Later.
How come last time no color now? What do you mean color? I mean like last time it's the staple one thing. Then it's not on now. Now still okay. No, last time.
Okay. Can you just write down your name and start already the lesson?
You got pen? Yes, I got all There's only one pen now. No, it's not color pen.
Oh, it's for my computer. Can you stop making strange noises?
Yes.
Just leave here for some.
You.
Okay, we're going to do another new topic called heat. Okay, so the syllabus. Why are you doing here? Huh? Why you never bring your pen one? You don't bring pen to school, man? Huh? Edwin, you don't bring pen to school, man? List some. Okay. The syllabus, you need to list some common sources of heat. You need to state that the temperature of an object is a measurement of the degree of hotness. Okay, so you need to know what temperature is. You need to know that there is a difference between heat and temperature. Okay, there's a difference between heat and temperature. All right, then you need to understand that heat flows from a hotter to a cooler region. That is the property of heat. Okay, start video. Huh? Okay, so then you need to relate the change in temperature of an object to the gain or loss of heat. When something gains heat, the temperature increases. When something loses heat, the temperature decreases. Okay, then you need to list some effects of heat gain. For example, when something gains heat, it will actually expand. When something loses heat, you actually contract. All right, then last but not least, in fact, the most important part of this chapter is to know what is called a poor conductor of heat and what is called a good conductor of heat. Okay, so first of all, what is heat? Remember last week, 2 weeks ago, we started off with the question, what is light? Correct, because light is a form of energy. And our main source of light is what? Edwin, what is our main source of light? Huh? Light bulb, no. The sun. The sun is our main source of light. All right. The sun is also our main source of heat. Without the sun, the world will be a miserable, very cold place. All right. So, like light, heat is a form of energy. Okay. So it is not a matter because matter occupies space, matter have mass. Energy doesn't have mass, doesn't occupy space. Okay. So heat made things hot. A lack of heat made things cold. Okay. So if you have a hot cup of coffee, that means it has a lot of heat. So the temperature is very high. If you have a cold can of coffee instead, then that means the temperature is very low. Okay, it has very little heat. A heat source is any object that produces heat. Okay, so the heat source for Earth is mostly the sun. The sun heats up the Earth. Okay, what are other heat sources? It could be geysers, volcano, and wildfires. These are natural sources of heat. But increasingly, wildfires have been the cause of humanity. That means humans make wildfire. Most of the wildfire you see now are not in fact wildfires. Actually, someone who Like maybe they set a fire, they do camping or whatever, and this fire went out of control. Okay, so most of the wildfire now are not natural. They are actually caused by humans. Okay, a heat source is any object that produces heat, and some examples of sources of heat are these four. Okay, the sun is our main one. All right, so there are man-made sources of heat. For example, a candle flame. Is there a candle existing in this world? Is there a candle existing in this world without humans?
No.
No. Okay. Is there an electric iron without humans?
No.
No. So these four are sources of heat we use in our house. Okay, maybe not candle flame. Electric iron, hair dryer, and oven. Candle flame, we don't use it often nowadays. Okay. So the sun, we have learned that the sun is actually our main source of light. The sun is also the Earth's main source of heat. The sun provides heat for living things to maintain their body temperatures in order to survive. Okay, we need to maintain our body temperature. We are warm-blooded animals. We are warm-blooded. We are mammals, so we are warm-blooded. All mammals are warm-blooded. All birds are warm-blooded as well. Okay, so we need to maintain our body temperature. Does that mean that reptiles don't need to maintain their body temperature? In fact, reptiles need to heat themselves up if they are going to move. So if at night the reptiles don't move much because the reptiles don't have that much heat. Okay, so have you seen a tortoise in the zoo? They are like sunbathing because they want to heat their bodies up. Okay, so that they can move around. Okay, so they also need heat. Even though they are called cold-blooded, they are not literally cold. Okay, they just require some sunbathing to heat up their bodies. Okay, start your video. Heat from the sun also allows water to evaporate and condense, providing living things with a constant supply of fresh water. So this you will learn in P5. The last point, you are not that interested as of now. Okay, so the uses of heat. There are many uses of heat. Okay, Ricardo, can you give me some examples of uses of heat in your life? Yeah, cooking. We need food. We need heat to cook food. Can we eat raw food? We can eat sushi. The meat is raw, but there's many things we can eat raw, but eating things raw is not as delicious and not as nutritious as cooking it. Cooking it makes digesting the food easier. Okay, heat is used to cook food. It is used to dry our clothes. It is used to kill germs and bacteria. They are used to maintain our body temperature. If we don't have that much heat, then we cannot maintain our body temperature and we may even die. And we also use heat to generate electricity. Okay, this one again, you'll learn it later on. I'm not going to talk about it much. Temperature. Okay, temperature is very important. Now we have COVID-19. We know that if you have a virus, most of the time you have a fever. Okay, when you have a fever, that's when you can spread the disease. And therefore, in every supermarket, in every shopping mall, in your school, there will be temperature screening, right? Do you all screen your temperature?
Yeah.
Yes, right? So there will be temperature screening. If a temperature is too high, you can't get into the shopping mall because so the temperature is used to measure how hot you are. Okay, so if your temperature is above 37.5 degrees Celsius, it is above the normal human temperature, so it is you're considered to have a fever, and therefore you're not allowed to go into the shopping mall. All right, so human body temperature is actually a very narrow range of temperature. It cannot go like 1000 degrees Celsius. It won't be like you screen your temperature, it says 1000 degrees Celsius. You're like, what? Okay, the temperature of your body, once you go even above 42, you're dead already. Okay, 42 is still possible, but 43, you're dead already. Okay,
42.1.
it's possible. 42.1 is possible. Okay, so if your human body temperature goes to 34 point something is wrong also. That means you will die as well. Too cold. Okay. So thermometers are designed for different uses. If you are a clinical thermometer, that means a thermometer used to measure humans in clinics, right? Clinics are only for humans, right? Okay. If you go to a clinic, the clinical thermometer is only going to be used to measure the temperature of human bodies. Do you think it needs to have 100 degrees?
No.
No. Nobody is going to be even close to 100 degrees Celsius, right? The person will die, right? So the clinical thermometer doesn't need to measure the temperature of very high and very low. It just needs from 35 to 42. They don't need a thermometer that measures 50. No, it doesn't need a thermometer that measures 60 because the human body will never reach the temperature. If you reach the temperature, you're dead already. So the clinical thermometer is used to measure the temperature of a human body. Therefore, it doesn't go above, okay, out of this range. It doesn't go below 35. It doesn't go above 43 or 44. Okay, it has a narrow temperature range as a human body can only stay alive at this narrow temperature range. But then when you're talking about a laboratory thermometer, you have a wide range of temperature because usually in a lab, you want to measure water. You want to measure the temperature of water. Water actually can heat up until it's 100 degrees Celsius. Okay, that's the boiling point of water. And then the freezing point is 0 degrees Celsius for water. So the thermometer in a laboratory is usually used to measure temperature from -10 to 110. Why don't they measure temperature higher than that, like 200, 300, 400? Do you think the heat will get that high in a laboratory? No, because if you have 500 degrees Celsius, it's actually a super, super hot thing. So they don't have a thermometer that measures. In fact, you're not even supposed to stick a thermometer into something that hot. You are supposed to use an infrared thermometer. Because if you stick something into the flame itself, it will get damaged by the flame. Okay, so even in a laboratory thermometer, your temperature is not supposed to be that high as well. But it's definitely higher and lower than human body temperature. Okay, so a laboratory thermometer can measure the temperature from -10 to 110. 100 degrees Celsius is boiling water. It's like your soup, right? Let's say you use hot coffee. The hot coffee is around 80 to 90 degrees Celsius. Okay, so now the difference between temperature and heat is this. I want you to think about an example. Do you think okay, let me ask you something. Here I have two things. A is a drop of 100 degrees Celsius water. 100 degrees Celsius is boiling temperature. It's very hot, right? Yeah. Then you have a bathtub filled with water. The bathtub filled with water is 90 degrees Celsius. So which one do you, wow, the temperature of A is higher than temperature of B. So that means you will rather jump into a bathtub filled with 90 degrees Celsius water than to, so which one do you think will kill someone? Is it the drop of 100 degrees Celsius water or the bathtub filled with 90 degrees Celsius? No, only 100 degrees Celsius, one drop of boiling water won't kill you. If not, the person who fry kway teow and fry Hokkien mee every single day will die. Because when they fry the Hokkien mee, the oil will come out and touch him, right? Does he die every single day? No. Does he die 10 times a day? Because when you fry something, the oil will spill over, right? So imagine you, then the oil touch you, boom, boom, you die. You don't, right? Because even though one drop of 100 degrees Celsius water, the temperature is high, but because the volume of the water is so little, the mass of the water is so little, it won't kill you. You don't have enough water, you don't have enough heat. So does temperature represent everything? No. There's another factor, that is the amount of water you have. The greater the amount of water you have, the more heat it can contain. So if someone jump into a 90 degrees Celsius hot water, the person will surely die. Even if they don't die, it will be seriously injured. Okay? So that's the difference between temperature and heat. Okay? Temperature measures the degree of hotness of an object. You have to memorize this phrase, degree of hotness. But it is not everything that determines the total amount of heat. It is just half the story. The full story is, do you have enough water? Do you have enough mass of substance? Okay, if you have a lot of mass or a lot of volume and also a very high temperature, then of course you really have a lot of heat. But if you have a very high temperature but very little volume, then that means you don't have a lot of heat. Okay, so the example here shows that if your water is 30 ml, the same amount, okay, if your volume of water is the same, then you can compare the temperature. The higher your temperature, the greater the amount of heat. Only when your volume is the same, then you can compare the temperature. Okay, if you have the same temperature, you can compare the volume of the water. If both water is at 80 degrees Celsius, the one with greater volume will have more heat. Okay, I say again. The one with greater temperature, the one with higher temperature, okay, sorry, both of them have the same amount of temperature. So the one with the greater volume of water will have more heat. Just like one drop of boiling water versus one pail of boiling water. Okay, someone offer me one drop of boiling water touch your skin, I give you $10,000. Sure, nothing will happen to me. One drop of boiling water, at most I'll feel pain for 1 second. Then after that, nothing will happen because that water will lose heat to my body. Then it cool down. Then I'll get 10,000. 10,000 won't get you rich lah, but it's a free $10,000. But if someone offer you, I'm going to give you $100,000, but you pour one bucket of boiling water over your head, is your life only worth $100,000 because you are going to die after that? Okay, all your hair is going to drop off, so you become botak. Okay, so make sure you know the difference. Okay, so you can have the same temperature but a lot more heat because you have a lot more water. Okay, so the water in beaker D has more heat since the water in both beakers have the same temperature, but the water in beaker D has a greater volume of water. Okay, among the 4 beakers of water, beaker D has the most, has the most heat because it has the highest temperature and also the greatest volume of water. So which one has the least amount of heat? Beaker A, because it has the lowest volume and lowest temperature. Okay, can you compare beaker B with beaker C? Cannot, because one of them, actually cannot because the volume here is the same. Okay, can. So, okay, now we move to good conductors of heat and poor conductors of heat. Okay, on your table, is there anything that's metal?
This one.
You touch the legs of your table. Okay, now then you touch your table, the wooden table. So which one feels colder? The legs of the table, which is metal, colder, or is the... So that means the legs of the table must have a lower temperature. True or false?
True.
Not true. You know why? Because the table is left, wait, Okay, actually, I think you need to add in something. I want you to, what is heat? I want you to write down here, heat flows from a hotter region to a cooler region. Okay, I want you to add in this. Heat flows from a hotter region to a cooler region. Okay, so heat will flow from higher temperature to lower temperature. Okay, so whenever you want to know whether you are gaining heat or losing heat, you always write your temperature. Okay. Heat flows from a hotter region to a cooler region. Okay, so our surrounding body temperature, our surrounding air temperature is around 25, 24. If you're in an air-conditioned room, it's around 24, 25 or 23. Okay, your human body temperature is 36, 37. So you're losing heat all the time. Then why don't we die? Remember I say heat flows from a higher temperature, regions of higher temperature to hotter regions to cooler region. So our body is hotter than the surrounding. So we are losing heat to the surrounding air. So why don't we cool down to the surrounding air? Isn't that an interesting question? Why did we? We are losing heat, because I told you, heat flows from a hotter region to a cooler region. So why did we die? Why did we reach the room temperature and die? The thing is this, our body produces heat all the time because our muscles, our organs, our cells inside us, they are working. And when they are working, they produce heat. That keeps us from dying due to cooling down to the room temperature. But if you place any other things, as long as it doesn't generate heat, it will cool down to the room temperature. So you look at the table, almost everything except your computer, because your computer generates heat, right? Because when your computer is working, it generates heat. Except for your monitor, your computer, and your cell phone and your devices, everything is actually at room temperature. So my pens are in room temperature. My mic is in room temperature. Okay, this can of coffee is in room temperature. My wallet is in room temperature. So why does metal feel colder? Since they are all in the room temperature. Because you see, if you are hotter than the surrounding air, you lose heat. Then eventually your temperature will be the same as the surrounding air. This is called room temperature. Okay? I say again, when you leave a can of Coke on the table, the can of Coke will lose heat to the surrounding air, right? So, so the can of Coke will lose heat to the surrounding air and the temperature will cool down. Okay, so so the temperature will fall and then it will be room temperature. So why does it feel colder when you touch metal? Very simple, because metal, yes, Edwin.
Why when we put something hot on the metal when we touch it, it's very hot?
Okay. Edwin say why when you put something hot on the metal, then you touch the metal, it feels very hot. Yeah, I'm about to get to the answer. Because metals are all good conductors of heat. That means when you touch a piece of metal, if the metal is colder than your hand, so there's two possibilities. The metal is actually three possibilities. The metal is higher than your temperature. That means it's hot. Then when you touch a metal, you will feel hotter than you touch wood. Okay? If you pour hot soup into a wooden bowl, and compared to you pour hot soup into a metal bowl. When you touch the wooden bowl, it doesn't feel hot, that hot. When you touch the metal bowl, it feels hot. Because good conductors allow heat to flow through quickly. So when you touch a hot bowl of soup, okay, remember to write down the temperature. The temperature, let's say the soup is 100 degrees Celsius, super hot soup. Then when your finger touches the soup, your finger is what temperature? I already told you, human body temperature is around what temperature? Healthy? 36 to 37, right? Okay, 35 is a bit too low. So yeah, it's possible, but it's not good. 36 is a good temperature. So you see, I told you heat flows from a hotter region to a cooler region, right? The hotter region is where the temperature is higher. So the temperature will actually flow from the hotter soup to your finger. Okay, so your finger will gain heat from the hotter soup. Okay, so if it's made of metal, the heat will flow very fast and then you're like, ouch, because the heat flows very fast. But if it's made of wood, then the heat will flow slowly to your hand, then you're like, doesn't feel that hot. Correct? But of course, you don't take your finger and dip it into the soup. Okay, the water is quite a good conductor, so you'll get burnt. Okay, so that is good conductors of heat and poor conductors of heat. So the opposite happens if you touch a piece of metal at room temperature. So just now I asked Hedwin and Ricardo to touch the legs of the table because it's metal. So we are in an air-conditioned room, so it's around maybe 22 degrees Celsius. The finger is 36, right? Yeah. So now when you touch the metal legs, now you don't gain heat from the metal leg because the metal is not, there's no hot soup to make it hot. So now you are touching a piece of metal at room temperature, lower temperature than your body. So your finger will lose heat to the metal leg and it will feel cold. So if it's a good conductor of heat like the metal legs, then your finger will lose heat very, very quickly. So when your finger lose heat quickly, it feels cold. So it is not that the metal has a lower temperature than the wood. They have the same temperature because they're all room temperature. If you leave something in the room long enough, all the temperature will become room temperature. Cold drinks will become room temperature. Hot soup will also become room temperature because they will either lose heat or gain heat from the surrounding air and then they will reach the room temperature. Yes? When we rub our hands, that thing is called friction. Okay, that one is you're learning in P6. Friction will generate heat. Yeah, good question. Okay, so when you touch a piece of wood or paper, it doesn't feel that cold because the piece of paper is a poorer conductor of heat than the metal. So when the question asks you, you have to compare better conductor of heat and poorer conductor of heat. Okay, so you'll say that, ooh, so if the question asks you, why does the metal can feel colder than the paper? Then you say, metal is a better conductor of heat than paper. So when our finger touches the metal, our finger loses heat to the metal can faster. So it feels colder. Okay? So that's the whole entire answer. All right, so we want to use so good conductors of heat, easy. Generally, they would say metals are good conductor of heat. So whenever they want you to say, give an example of a good conductor, very easy, is metals. Any kind of metals are good conductors, okay? So if they want a poor conductor of heat, then it is plastic. Plastic is a poor conductor of heat, okay? Okay, so plastic is a poor conductor of heat, metal is a good conductor of heat. Okay, so the handle of a frying pan, you want to use plastic because do you want to cook your hand? Wow, smells good. What is that? Ooh, barbecue hand. Wait. Right, you don't want to fry your own hand, right? So when you're frying, you want to protect your hands, so you use plastic to protect your hands. Okay, Evan, why are you using your phone? Is that something urgent? Okay, then the base of the frying pan must be a good conductor of heat because you want to fry the food fast, right? Do you want to use a poor conductor of heat you want to fry an egg for breakfast? Then you crack your egg, you put your egg onto the frying pan. One eternity later, 7 p.m. during dinner time, you're still cooking the egg. You want that? Your breakfast just became your dinner, and your teacher will call your parents. Where is Ricardo? Where is Hedwin? Not in school. Oh, he's still frying his egg. He has been frying it since morning. You wouldn't want that to happen, right? You wouldn't want that to happen, right? So the base of the frying pan should be a good conductor of heat because the flame should be heating up. And you want the heat to flow to the food to cook the food fast. So you use a good conductor of heat for the frying pan. For the base of the frying pan. The handle of the frying pan, you want to protect your hand, so you use a poor conductor of heat. So the heat will flow to your hand very slowly. Okay, so good conductors of heat allow heat to flow through very fast. Poor conductors of heat allows heat to flow through slowly. Okay. Common misconception, heat conductivity is relative. Okay, relative means there is no such thing called if you compare two things, you cannot say copper is a good conductor of heat. Copper is a type of metal. You cannot say copper is a good conductor of heat and steel is a poor conductor of heat. Why? They are all metals, so they are both good conductors of heat. So you must say copper is a better conductor of heat than steel. So whenever you are given comparison between two objects, please don't say one is a good conductor, another is a poor conductor. You have to say one is a better conductor of heat than the other. Okay, so use comparative words such as good, better and poorer conductor of heat. Don't say worse conductor. It's either poor or good. So when you use comparative words, okay, you say wood is a poorer conductor of heat than metal. Or you can say metal is a better conductor of heat. Better and poorer, not good or bad. Okay, Aloysius, you come so early. Now it's only 3:32, Aloysius. Wait, Aloysius, you're the P5 Aloysius, right? Oops, bye-bye. Expansion? Huh? I didn't kick you out. He came early. Just later, his lesson is at 5:15. Okay, expansion and contraction. Okay, the last one, expansion and contraction. When something gains heat, it will expand. When something loses heat, it will contract. Okay, so when you heat up something, it will expand. So that's why if you have a jug, if you take out a jar of peanut butter from, let's say a jar of chili sauce or whatever lah, from the, with a metal lid, it's hard to open it. So what do you do to it? Throw it on the floor, shatter the glass, then scoop up the chili. No, right? How do you open the metal lid? If you have a jug, okay, if you have a jug of, let's say jam or whatever, the metal lid is very tight. What can you do to make it loosen?
You dip the metal lid in hot water.
Yeah, you dip the metal lid in hot water. Okay, so why? Because when the lid gains heat from the hot water, it expands. It expands. So the exact explanation is in secondary school. Okay, so the exact explanation is in secondary school. So I'm not going to tell you now, but why it happens is because so it becomes tight. Why is it even tighter in the first place? Because the lid is made of metal. Metal is better conductor of heat. So when you have a better conductor of heat, when it loses heat, it will tighten around the jug. Because it is a better conductor of heat. That's why it loses heat faster. So you'll be very tight around the lid. So when you put it on a table, you have no time, maybe you're in a rush, you want this lid to loosen up. So you will want to heat it up. Okay, so when something gains heat, it expands. When something loses heat, it contracts. Contracts means it becomes smaller. Okay, so that is heat. Thermal expansion. Thermal expansion means something gains heat, it expands. Something loses heat, it contracts. So the perfect example to show this. Okay, when it contracts, that means it occupies less space. You have learned metal, right? When it contracts means it occupies less space, it becomes smaller. When it gains heat and expands, that means it occupies more space, so it becomes larger. All right, so this is the classic example of a thermal expansion experiment. When you heat up the metal ball will gain heat and expand. So at first, they will show you that the metal ball can pass through. But later on, when you heat it up, it cannot pass through anymore. Because the metal ball becomes slightly larger because it's gained heat already. So slightly larger is enough to be larger than the hole. Now it cannot pass through the hole. Okay, so this is the perfect example to show that when something gains heat, it expands. Okay, so other effects of heat gain and heat loss includes a solid will melt if it gains too much heat at its melting point. You learn melting. Melting point is the temperature where a solid turns into a liquid. You learn that in P5. Ice will also melt when it gains heat. Water will also dry up. It's called evaporation. You learn in P5 when it gains heat. Okay, when it loses heat, it also can change from one state to another. When you lose heat, you will turn from liquid to ice, from water to ice. Okay? All right, so when you gain heat at your boiling point, for water, the boiling point is 100, you will also boil. Okay? The boiling point of alcohol is slightly lower. Okay, this one. When you lose heat, you can also condense on a surface. Have you seen water droplets on cold water before? Definitely, right? Unless you have been living under a rock. Okay, so this water droplet is because you have a cold surface. Then you have warm water vapor. Water vapor cannot be seen. Water vapor is water in the air. You cannot see it, but it's there. But when the invisible water vapor touches the cold surface, the water vapor loses heat. When it loses heat, it condenses to form water droplets. Okay, so that is called condensation. Okay, I'm not going to spend too much time on this because it's actually P5 stuff. So now, yes, Henry? Wait. Don't keep thinking about this computer. Right now, you don't need to use computer. Humans understand that method expand after gaining heat and contract after losing heat. That's why, can you see the train tracks have a gap between them?
Yeah.
You know why?
Because stack together.
Ah, if they are too close to each other, what will happen? On a hotter day, the train track will gain heat from the hot air or sunlight and it will expand and become longer. When they become longer and you don't give a gap between them, they will push on each other and bend each other. Then the train, it will go off track and people can die. Many people died because of this before. Okay? Hundreds, even thousands of people. If the train go down a mountain, then everybody in the train will die. Okay, so the train tracks need to have a gap between them. So things are designed to expand if they are going to be heated up. So if you put your train track under the hot sun, then of course it will be heated up. So you need to give some space for it to expand. Okay, the opposite is true for this electricity lines. Okay, in Singapore, all the electricity line is buried underground, so we don't see it. That's why Singapore is so neat and tidy. Okay, in most countries, it is above ground like this. So why must it be so loose? Why are they using so much metal? Are they wasting metal? No, because if you make it too tight, on a hot day, it will become even tighter. Too tight. Okay, you see, this one is sagging, right? It's longer than needed, right? If you make it too tight, a very, very short line, just nice to reach the two. So if you have just nice enough wire, on a cold day, it will lose heat and contract and become shorter. Then what will happen? It will snap. It will snap. Then the electricity will be cut off. Okay, so this is to prevent contraction from snapping the line. This one is to prevent expansion to damage the train tracks. Okay, so that's thermal expansion. Okay, I'll let you all watch a video, some videos. Yeah, now. Wait, let me launch the video first.
That was my own.
Are we?
That was my own.
Yeah. Go toilet. Yeah, go.
I'm watching it.
Wait, Oh, no. You watch through my Zoom?
This one better. Hold on.
Okay.
Small gaps left in between rails. Don't know the answer? No worries. We shall find a solution.
Oh.
Hey, did you notice that the level of mercury in the thermometer rose when it was placed in hot water? You must be wondering why this happened, right? It happened because of thermal expansion. Thermal expansion is the tendency of matter to expand on heating. This tendency of expansion can be observed in solids, liquids, as well as gases. Now, let us see how this concept of thermal expansion applies to a thermometer. A thermometer usually consists of a narrow tube with a small bulb at its one end. The bulb and a part of the narrow tube is filled with mercury, which is liquid at room temperature. Now, when a thermometer is placed in hot water, mercury inside it expands due to thermal expansion, and as a result, its level rises.
Huh?
Yahoo! Yahoo!
Huh? Oh. Ah. Huh?
You must be thinking how the gasoline came out of the tank, even though it was exactly filled till the brim. Am I right? Gasoline also expands on heating. So, what happened is that when the tank was filled till the brim, there was no space left in it. Now, when the bike was kept in the sun, the tank became hot, which eventually heated the gasoline filled in it. As a result, the gasoline expanded.
So when the
But
gasoline
since there was
expands,
no
there's not enough
space
space,
left in
right?
the
So you
tank,
overflow, right?
expansion forced gasoline to come out of the tank.
Huh? Hey! Huh? Oh yeah! Oh. Huh?
Does that ever get?
Do you think that the rails
Oh.
bent because of thermal expansion? If yes, then you are absolutely correct. A railway track is made up of a number of rails joined to each other. These rails are usually made up of steel. Steel expands on heating and contracts on cooling. When the rails are joined to one another without leaving any space for expansion, the rails bend due to thermal expansion and the train goes off the railway track. To avoid this, the rails are not joined together firmly. Instead, each rail is connected to the other in such a way that a small gap is left in between them. These small gaps provide space for easy expansion of the rails, which happens during summer, as well as due to continuous friction between the train wheels and the rails. Hence, these small gaps prevent the rails from bending, preventing any kind of accidents.
Okay, so that's thermal expansion. Okay, ball and ring experiment. Okay, this is a ball and ring experiment. You'll find that before hitting the ball can pass through. Later you'll see that after hitting the ball cannot pass through. Yeah. Can you see it's gaining heat until it's heated red hot already?
Yeah, I see it.
Hot, right? Now you can see it cannot pass through it. Because the metal ball gain heat from the flame. Whenever you say gain heat, you have to say gain heat from where? The metal ball gain heat from the flame and expanded. So it becomes larger than the hole, so it cannot pass through the hole. Now it's cooling it down. So now the metal ball lost heat to the water. Okay? Remember, when something loses heat, something must gain heat. Because heat cannot be destroyed. Energy cannot be destroyed. So if something loses heat, something must gain heat. So the water gain heat. That's why it boiled off to form steam. Okay? But the metal ball, it contracted back to its original size. Okay, it contracted back to its original size. You can see that now it can pass through again. Okay? So this shows that, okay? This shows that when something gains heat, it expands. Okay, we are going to do the MCQ. I'm going to give you 10 minutes to finish all the MCQ. Just try, even if you don't know, it's fine. do until question 15. Question 15, I think 15 minutes. 15 minutes to do. Why? You see whether you can finish first? Oh wait, I don't. Google Master.
Oh, that's good. Rush to walk with that.
Come on, very bad.
If the robot hits you again, because the robot gonna scan this virus will travel to your brain.
Don't do your properly later, no robot. If you want to play the robot, you better behave. Hmm?
Ice cream.
Let me know when you're done, if you're done.
When it's 15 minutes.
I don't know, you have to finish first. There's no keyboard, you can use the keyboard.
So I think I saw.
There is keyboard, but I'm using there's another keyboard.
That he's full Chinese. Chinese 有转弯。呀。
You is not Chinese. Zheng, right? Ricardo, what's your surname? You is you is what? I know. Wait. Your Chinese is what? Huh? Chinese, your Chinese name is what?
I don't know what you mean.
No, I know. Like, what's How do you, what's the surname called?
In Chinese. Surname.
Uh,
No.
no, Diu is English. You don't know your own Chinese
I
name?
know everything. I think it's Zhang.
Oh.
Zhang.
Oh, you don't know. You don't know what is your own name? Zhang, okay, Zhang.
Yeah, I know. Alright, yeah, okay. Pronounce your own Chinese name. I know. Yeah. 你忘说了 yellow bee 啊？多杯啥吗？Oh, so you get top better. Yeah, I get top. Always get top. What's your room?
Yellow one.
Yellow.
New one.
You know my highest score is summer. You know my highest score for summer? What's your highest score for summer? 750. My highest score
They
is
didn't have new one.
130.
Because I want to take a.
Oh. That right, that left. No, you must step right. You put double right, step right. Step right, then step left. Then you put left, right. Then you put left, right. But you put one up the row, then you put right, and then you put right, then right,
I think the blue one was me because the color like this is because the blue one. Later you can, yeah, after that you can change back lah this one.
So all the three, yellow.
I think no, magenta is okay. You can see the magenta is fine. No, the magenta is fine.
Yes, right.
Then this one is the one that is like.
You know, actually, I just gave up. No, 430. Impossible. Impossible.
I think we can print the date one.
How do I see your name? How do I see your name? You don't say someone.
Yeah.
How do I see your name? Oh my God, you kidding me?
Okay, sit down. Can we go through? Have you done?
Yes, we don't have any pardon.
Raven, are you done? Okay, let's go through. Okay, since you all don't want to see properly, that means I think you all don't want to play the robot already lah. It's fine lah. Question 1. Okay, Raven, what's the answer, Raven?
Number
Number what?
Number 2.
The hot water is the heat source, correct?
Yeah.
Okay. The heat source is the hot water that provides the heat to heat up the milk. The diagram below shows the same amount of water in the kettle and in an iron pail. The water in the kettle and the water in the iron pail were both at room temperature. They were allowed to boil. Which of the following will happen? No, the water in the pail will never boil. Why? It will eventually boil. The answer is the water in the kettle will boil first. Because can you see the bottom has a greater exposed surface area touching the fire? Okay, so the kettle has greater surface area in contact with the flame. So it will gain heat. It is a riddle. If you are observant, then the answer, okay, it's a difficult question because you need to be observant. The pail is smaller. The base is smaller, so it gains heat at a slower rate. It has less surface area in contact with the flame. Okay. Okay. Next, a man is given 4 pails of water in different temperature. He puts his hands into one of the pail of water for 30 seconds. Takes it out, then put his hands into another pail of water. He repeated this action a few more times and recorded down his observation. Okay, this one is actually quite difficult also. From A to C, his hands feel cool. From D to B, his hands feels cool. So if from A to C, his hands feel cold, that means A is colder than C. A is colder than C.
Yes, AC. So there's only one option, right?
Okay, then here D is
There's only 2 more.
D is colder. Oh, sorry, B is colder than D.
So the answer should be 3, right?
Wait,
Yeah.
Then when you move from D to C, your hand feels warm because C is warmer than D. Okay, C is warmer than D. So D is colder than C. Then D to A, hand feels warm. That means D is colder than A. So the hottest is actually C don't have all? Strange. Let's check again. A to C, hands feel cool. Oh, sorry, A to C means C is colder than A, sorry.
C colder than A.
It's not A colder than C, my bad. C is colder than A.
Well,
When you take out from D and you put it in B, then hands feel cool, that means B is colder than D. This is correct. When you remove from D and put it in C, hands feel warm. That means C is warmer than D. Okay, D is colder than C, correct? Okay, from D to A, hand feels warm. A is the warmest because A is not colder than anything. A is the warmest. Okay, B is colder than D. D is colder than C. So B is the coldest, followed by D, then C. Answer is 4. Okay, so when you take it from A and you dip it in C, if it feels cold, that means C is colder than A. Done? Which of the following is a heat source but not a light source? Ricardo, what's the answer? 2. A basketball is a heat source? Why would a basketball be a heat source? Hair dryer. Hair dryer. Hair dryer blows very hot air, right? Hair dryer. It's okay. It's okay. Stop competing every single question. Sometimes you get correct, sometimes you get wrong. It's normal. Then, question 5. Jim has 4 cups of water as shown in the diagram below. Which of the following statements is correct? All the cups of water have the same amount of heat. True or false? All the cups of water have the same amount of heat. Not true, right? The one that have the most heat has the greatest amount of volume, greatest temperature. The water in cup C has less heat than the water in cup B. True, because C has less volume than B. B got more volume, that means it got more heat. Okay, answer is 2. The water in cup C has less heat than the water in cup B. Correct. Cup B got more heat because they have the same temperature. They have the same temperature, but B got greater volume. Understand? Okay, so 6. Why suddenly got which of the following is not matter? Even though it has heat. Okay, have we know what's the answer?
4.
Air is a matter. Heat is not a matter. Light is not a matter. Shadow is not a matter. Answer is 4. Yeah. Question 7. The car tire is made out of an outer rubber tire with an inner metal ring. So the outer rubber tire wraps around the metal ring. Which of the following explain what will happen to the metal ring and rubber tire on a hot day? The outer rubber tire expands less than the inner metal ring. This is true. Because the outer rubber tire is a poorer conductor of heat. If you are a poorer conductor of heat, you will expand less. The outer rubber tire expands more, not true. The inner metal ring and the outer rubber tire remains the same size, not true. They will expand. The space in the center of the rubber tire will be bigger, no. Answer is 1. Because the rubber tire is a poorer conductor of heat. The outer rubber tire is actually a poorer conductor of heat than the inner metal ring. Okay? Which of the following is an example of metal gaining heat? Solid butter melting on the dining table. Is it gaining heat?
Yes.
It is gaining heat. Liquid water freezing into solid, that is loose heat. Metal bar becomes slightly shorter after placing in a freezer. Loose heat, that's why it contracts. Spoon become cold again, loose heat. The only thing that gain heat is the butter gain heat and melted. Okay? Question 9. 3 beakers A, B, and C contain different amounts of water. Each beaker of water is heated. Do you need more heat to boil more water? You need, because imagine you try to take a candle flame. If you don't need more heat to boil more water, then you take the candle flame and you take a Bunsen burner and start heating up the Pacific Ocean. Do you think all the whales and the fish will all die? Do you see all the crops surface and all become cooked? Do you have a big pot of seafood the size of the Pacific Ocean? No, you know why? Because the ocean has too much water already. It's impossible to heat up the whole entire ocean with your millions of candles. Not even millions of candles will do anything to the temperature of the water. Millions, of course, the sun crash into Earth, the whole entire Earth will be gone already. Yeah. But the thing is, nothing that humans create can boil off all the water in the ocean. So you see, can you see that the more water it is, the more heat is needed to boil the water? So which one will boil the fastest? C, because the water, it has the least amount of water and the most heat, right? Yeah, it has the most heat and it has the least volume of water. So which one will take the longest time to heat up, to boiling? A law. It has the least amount of water, most amount of water, least amount of heat. Which of the following statements about the beakers of water is true? Water in beaker A has the most heat. Actually, this is very tricky. Each beaker of water is heated until the water boils. Okay, that means they did give it enough time for the water to boil. So when water boils, what temperature is it? 100 degrees Celsius. Actually, you haven't learned yet. 100 degrees Celsius. So they have the same temperature, in fact. They have the same temperature, in fact. So which one is actually the one with the most heat? C. No, it's A. C is the easiest to heat until boil. But the question say each beaker of water is heated until the water boils. Okay, understand what I say? So it's a very tricky question. Even though this has the most heat and this has the least water, it is supposed to boil first. The second to boil is beaker B, the third to boil is beaker A. But the question already say each beaker of water is heated until the water boils. That means they all have the same temperature, 100. And therefore, the one with the greatest volume will have the most heat. Okay, just like I said, one drop of hot water will kill you or not? No, one drop of hot water won't even hurt you. If not, every single person who fry kway teow every single day, they have to die 5 times already. Okay? So if you cannot take heat, you don't play later. If you cannot take hot things spilling onto your skin, you cannot fry kway teow already, because every single day you fry kway teow, there will be hot oil spilling on you. Okay, it won't kill you lah. If not, If not, nobody wants to do that job already. It's confirm you will die one. Okay? Or you very gently fry the kway teow. Then the queue will have 20 people, everybody will take you. So slow. Because you're too gentle already. Cannot be, right? And do you think in the kway teow that you fry is nice if you're so gentle and slow? Right? So you see, one drop of hot water spill onto your skin, nothing will happen to you. Even though how hot it is, it doesn't matter. 2 liter volume. So 1000 also won't kill you. 1000 degree also won't kill you. Anyway, water cannot go up to 1000. Oil cannot go up to 1000. It can only go up to its boiling point. Because once it reaches its boiling point, it will turn into a gas. So it cannot reach 1000. Okay, it cannot reach 1000. But even one drop of $1000 degrees Celsius water also won't kill you. Okay, even if it's possible, it won't kill you. But one beaker of 100 degrees Celsius water, you accidentally pour on your hand, prepare to go to hospital at least a few weeks. Okay, because that will make your skin die, and then you will suffer burns, super painful one. Burns are the worst thing to suffer. It's very painful. Okay, if someone get cut, it's also not that painful. Just stitch it back, then you grow back. Not that painful, but burns are the worst. Okay. The answer is 1. Water in beaker A has the most heat. It's true because they all have the same temperature, but A has the greatest volume. Water in beaker A has the lowest temperature. No, they all boil, and boiling water can only be 100 degrees Celsius. You will learn it in P5. Water in beaker C has the highest temperature. No, they have the same temperature because boiling water all is 100 degrees Celsius. Water in beakers A and B has an equal amount of heat. Not true. A got less heat, more heat than B because B has less volume of water. Okay? Heat is lost when matter changes its state from a solid to a liquid. Just think about water. Solid is called what? Ice. Liquid,
Liquid is water.
Water is, what is this called? Ice turned into water is called what?
Melting.
Yeah, melting. So heat is lost when ice melts. Ice need to lose heat when it melts. True or false?
True.
Think again. Ice need to lose heat or gain heat to melt? Just think about the ice and the surrounding temperature. If you want to know whether something gain heat or lose heat, you just think about the ice and the surrounding temperature. The ice is 0. The surrounding temperature is 25. Heat flows from a hotter region to a cooler region. So the ice lose or gain heat? Gain, because heat flows from the hotter surrounding air into the ice. So the ice gain heat, the surrounding air lose heat. So melting require heat gain. They want heat loss. A liquid to a solid is freezing. Freezing require the water to lose heat. True or false? Freezing require water to lose heat. True or false? Again, I want you to remember how to set. In a freezer, the surrounding air temperature is minus 20 degrees Celsius. The water is room temperature, 25. So will the water lose heat or gain heat? Heat flows from a hotter region to a cooler region. Which one is hotter? Negative 20 degrees Celsius air is hotter, or the water inside the cup is hotter? The water inside the cup is hotter. So heat flows from a hotter region to a cooler region, from a hotter object to a cooler object. So the water lose or gain heat? Lose heat. And therefore it freezes. So freezing requires heat loss or heat gain? Heat loss. That is how you check. That is how you check. Label all the temperature. And then you ask yourself, heat flows from a hotter region to a cooler region. So does it gain heat or does it lose heat? Understand? A liquid to a gas. A liquid to a gas is called evaporation. It requires heat gain. Okay, if you have a puddle of water under the hot sun, the water will gain heat from the surrounding air and the sunlight, and it will evaporate very fast.
Yeah, so it's a gas.
So it gain heat. A gas to a liquid is called condensation. Condensation requires heat loss. Okay, this one actually only P5 you learn. Answer is B and D, 3. Okay, if you don't know how to do this, it's okay. P5 you learn it. Okay. So heat and water is closely related because heat is required for water to change state. Melting requires heat gain. Freezing require heat loss. Condensation require heat loss. Evaporation require heat gain. Boiling require heat gain. So all these things either require heat gain or heat loss. So if you want to be good in water, you also need to know. You need to also be good in heat because you need to know whether it gains heat or lose heat. Question 11. Miss Ang showed her students a metal ball and a ring. The ball is slightly too big to pass through the ring. How about Raven? What's the answer?
Number
Question 11. What's the answer?
1.
1.
Oh, sorry. I mean 2. Yeah,
Okay.
1.
1. Okay. Hit the ball using a Bunsen burner. You see, the ball is currently slightly too big. So you want it to pass through the ring. You want the ball to contract. Okay, is it a normal metal ball? No, the normal metal ball, just now the experiment I showed you, the normal size of the metal ball should be smaller than the ring. But in this question, they say the ball is too big to pass through the ring. So you want the ball to become smaller. That means you want it to contract. If you want it to contract, you need it to lose heat. Okay, or you can let the ring gain heat, right? Or you can heat up the ring so the ring expands. Now the hole will be bigger than the metal ball. Heat the ball using a Bunsen burner. No. Place the ball in ice water. True. Place the ring in the refrigerator. That will be even smaller. Place the ring in ice water. No. Answer is 1. Okay, good. Celine accidentally left a bowl of ice cream on the table. Like I said, label the temperature. The ice cream, I will label it as 0 degrees Celsius. Usually ice, you will say 0. So it may be lower than 0, but as an example, you don't need to be that accurate. The surrounding air is, let's say, 25. The table and, okay, when you take the cup is also 25. Everything is 25 at first because it's all kept in the room. When everything is kept in the room, anything hotter than the room would have lost heat to the surrounding air and cool down to room temperature. Anything colder than the room would have gained heat from the surrounding air and become the same temperature as the room. Okay, that's why everything in your room should have the same temperature unless it is placed near a window, some sunlight is hitting it, etc. If no sunlight is hitting it, then everything in your room except for heat sources will all be at room temperature. So can you tell me something? When you're in a room, there will definitely be something that is hotter than the room temperature. What is it? When you're in a room, there will definitely be one thing. Confirm one thing. What? Yourself, yes. Because if you are the room temperature, you're a dead body already. Only room temperature can reach a dead. Only a dead body can reach a room temperature. So if you are in a room, I already told you, if you are in a room, then of course your temperature will definitely be higher than the surrounding air. Because you are a heat source. Human beings, our temperature is always around 36 to 37. Okay, so there are also other things that will be hotter. For example, my room, I think the hotter thing is not even our bodies. The hotter thing is probably the projector. The projector is very hot. Okay, so the second hottest thing is probably my lights here. Actually, my lights are not. Maybe my body already. Maybe the camera. Okay, maybe my monitor. My monitor is also quite warm. The projector, just now I already said the projector. I think maybe my monitor is the second hot thing. Okay, so anything that works and uses energy will be slightly hot. Okay. So you see, heat flows from a hotter region to a cooler region. So basically, everything is losing heat to the ice. Everything is losing heat to the ice cream. The surrounding air is losing heat to the ice cream. The cup is losing heat to the ice cream. The table is losing heat to the ice cream. Everything is losing heat to the ice cream. The only thing that gains heat is ice cream. Okay, ice cream has lost heat to the surrounding air. Not true. It gained heat because heat flows from a hotter region to a cooler region. Okay, it's just like money. Money. If let's say money Money flows from Mr. Chong to the students. That means Mr. Chong lost money. Students gain money. You get what I mean? Whether it's gain heat or lose heat is very simple one. You need to know where the money flows. So if Mr. Chong, if I tell you money flow from Mr. Chong to you, that means Mr. Chong lost money, you gain money. Same for heat. If the ice cream is colder than the surrounding air loses heat to the ice cream. So that means the surrounding air loses heat. The ice cream gain heat. Okay? So when something loses heat, something else must gain heat. The heat cannot be disappeared. So that means right now you're using air conditioner. The heat must go somewhere. Where do you think the heat goes? Huh? Where do you think the heat goes? No, the heat must go somewhere. It cannot all be stored in the air conditioner. If not, your air conditioner is a bomb already. Then later off, it explodes, releasing heat back into your... Okay, there is something called a condenser unit. Okay, so actually, you are not making the world colder. In fact, you're making the world hotter by using aircon. Because why? There is a condenser unit with a fan outside. Okay, the fan is the one that will speed out the fan is going to be the one that will blow out the hot air. You don't believe? You go to one of these condenser unit, you can feel hot air blowing at you. Okay, so the aircon is actually, the aircon is blowing cold air in your room. So all of our hot bodies will lose heat to the cold air. Okay, the heat don't disappear. The heat is actually being expelled through this fan. Okay, because the cold water that goes into your aircon will be heated up by your heat sources. Then this cold water will be pumped out. It needs to be cooled down again. Then this cold, it's not really cold water. I think it's like a refrigerant. It will boil very easily. But anyway, it needs to lose heat. It needs to lose heat before becoming cold and come into your room again. Okay, so there will be a place where the hot, you can think about hot liquid inside your inside your inside your air conditioner. It needs to pass out somewhere. So the heat don't disappear. Heat will never disappear. It will just convert from one form to another. That you learn in P6. It's called energy conversion. Okay, so last time my room, when I used to live with my parents, my room is an oven. You know why? My room here, there's a refrigerator. Like I said, right? If it wants to cool down the things inside, there must be a place where it passes out heat. The refrigerator passes out heat at the back. So my wall, this left wall is always warm one. So my room is super hot. Okay, it's a terrible room. It's a super lousy design also. Okay, it's a super lousy design. That is why we need to use science and our brains when we design a house. Some architects, I don't want to say but it's pretty. They don't think They don't think and that's a big problem. You spend quite a lot of money buying a house. In the end, they go and design. Oh, the refrigerator is going to be back facing one of your room. Isn't that silly? Isn't that silly? It's super silly because that place is a cutout, and that place is clearly meant for a refrigerator. And yet the refrigerator is placed at a place that will expel heat into another wall, which is super silly. Okay, you want to expel heat, you go and expel to the outside air . You let your refrigerator face the outside air. Then you pass the heat out to the outside air, no problem . You go and pass it to another room for what? Okay, so there are a lot of silly things that architects do that they never use their brain. And okay, for example, another example. Last time I used to have a helper. Okay, that time she's carrying a pail of shallow hot water. Okay, so she uses a pail with hot water because that time I think it was to make some herbal bath. Okay, for some skin condition. So this hot water is very shallow only, but because my bathroom, the tiles that came from the government is super slippery tiles. Tiles, that means the flooring tiles. So they also never use their brain and they just make the ceramic, but because that time we don't really want to use the toilet, we use our own bedroom toilet. So we never change the tiles in the living room toilet. So my helper went in and slept down, and then all the hot water spilled over her body. Luckily, it's not a lot of hot water. She got like 10% of her skin burnt. Okay, so she went into hospital. Then in the end, we spent $14,979. I can still remember. We spent $14,979 for using the artificial skin to let her recover faster. Okay, in the end, luckily the insurance is $15,000. Just nice cover. Just nice cover her hospital bills. If let's say she stay one more day, it's already very bad. Anyway, it's already very bad lah. She got injured. So you see the flooring tiles, the architect didn't even use their brain to think about, hey, maybe my flooring tiles shouldn't be super slippery. This is common sense, right? Yeah. Common sense that anybody with P6 knowledge should know that the floor tile shouldn't be that slippery. Okay, but usually we dry the toilet, so and then we don't move very fast. Okay, but this helper, she do things very kanchong one. That means she want to rush here, rush there. We never ever tell her to rush. So she went rush here, rush there, then she slipped and fell. Okay. It was very scary. She just screamed, ah! Then I was like, what? Then I saw then the hospital, the ambulance came. Okay, so as an architect, you need to design where need to gain heat, where need to lose heat. Everything must be planned properly. Okay, ice cream has lost heat to the surrounding air. Not true. It gained heat. Ice cream has gained heat from the surrounding air. True. Surrounding air has gained heat from the ice cream. Not true. Surrounding air has lost heat to the ice cream. True. B and D. Answer is 4. We will stop here. We will do game kit. Trust no one with 3 people. Fun me. I don't want to join. I'm lazy. I don't want to join. I don't want to join. I'm lazy. Floor is lava lah.
No.
Infinity mode.
No.
Okay lah. Wait. You know that my computer is not a supercomputer, neither am I the Flash. So it takes time to launch the website. Just no one. You 3 lah. I don't want to join.
Okay. I'm 2 imposters.
No, 2 imposter cannot. 2 imposter to play 3 people.